2, 1. All right, so confidence intervals. I guess this is probably the last video, the 3 that I did. And this one is on trying to find the sample size if you want to have a particular margin of error. Now, that margin of error that you have in these kind of confidence intervals that you carry out, so if you recall from the normal distribution, and I will make that assumption that you have watched the normal distribution and you understand the confidence intervals, okay, within before watching this. So if you don't, by any chance, or you've forgotten, you may want to watch that introductory video on confidence intervals there. So if you recall, within the confidence interval, we want to try to find where our mean of the entire population might possibly lie. So within some interval, which we call our confidence interval, and then we have a certain amount of confidence level. So maybe 90% confidence level, no, 95% confidence level, or 99% confidence level. So those ones are the 3 most common ones, okay, that we run into. And what we have found is, if someone gives us some kind of a sample with n number of data collection points that we have done, then we can find the actual mean of that sample. Okay, so that was our x, little bar. And if we know, historically what the standard deviation for that particular result might be, then we can find out these confidence intervals. Now, what if you do not know, a priori, how big your sample size is, but instead you want to have a certain confidence level and you want to be, okay, within some margin, okay, so you want to have some margin of error, okay, within. So this will actually depend on how maybe a textbook or a teacher actually defines these margin of errors, okay, so I might define them a little bit differently. Okay, so what I would want you to keep in mind, so let's imagine, okay, so we have, okay, this interval, so let's say, so this right here, okay, so maybe, so this is somewhere on the number line, okay, right here, and that, okay, so is some number, okay, that we have. So I'm going to copy it, paste it down, so that is some number there, and then, okay, we have, okay, on the right hand side, okay, this, okay, number right here. So, and our confidence interval, so if I duplicate this, it's between those 2 points. So for instance, okay, if I go from all the way from here to here, this sometimes is called the width, okay, of the margin of error. All right, and it's divided into, kind of 2 things. So as you can see here, so the midpoint would have been, okay, so the midpoint is not our mean of the population. It is actually, okay, so if you, hopefully I'll put it up in the middle, okay, it is actually the mean of the sample right here. And then this distance, okay, that we have, so from here to here, so that distance from left to right, so that is nothing else but simply this right here, okay, so that is that distance. So if I duplicate this, all right, so that is that distance, okay, right there. So that's the green highlight that you see here. So that is equal to that. I actually call this, the margin of error that we might want to have. Now, sometimes textbooks will call the margin of error actually the entire width, and that entire width, okay, is going to be, okay, this, so the width, so they'll sometimes call it W. So that is the entire distance, okay, so going all the way, okay, from here to all the way over here. So that would have been the width that we have, okay, and then they call that. Now, if you are referring to the width, then width is obviously 2 times, okay, the actual, little error term that we have. So it's twice because it's computing it twice, okay? So that would, your width would have been. Now, if you know that, okay, and if somebody says that, okay, well, I want the width or this margin of error to be a particular size, and now you have a particular confidence level that you want to be within, and you know what the standard deviation is for your normal distribution, then you can isolate for n, right? You can actually solve this for n, okay, and then find out exactly what that result might be, and you might get a formula for it. So I personally don't really, like doing this with W. I just actually like doing it with this. So I'm going to duplicate this back in here. And what I say is that, okay, well, if I want some error term, so I want this to be less or equal to, whatever error that we are going to have. Because within your confidence levels, really you are kind of within, x and then plus minus this error term. And then your error term is nothing else, okay, but this z-score multiplied by the standard deviation divided by square root of n, and that's on both sides, right? So that's why I like having that, because it says plus minus right here, so we know what that is, okay? So, where would this possibly be applied, and what kind of examples you might see? So you might see something like this. So I'm going to just give you an example right here, so an actual word problem, okay, that we can solve. And this relates back to, really understanding our confidence levels and then computing the whole thing out. So let's say a company is trying out a new process of making vitamin C tablets. Now, over the company's history, okay, the standard deviation for making tablets has been 2.5 milligrams. Okay, so we have that. So I'm going to just write this out here. So for my given informations, so given, okay, so my standard deviation, okay, in historical terms for this company is 2.5 milligrams. If the company wants to report with a 99% confidence level, okay, so my confidence level, so if you recall, okay, so this is 1 minus, okay, the threshold or the confidence level in general, so this is 99%, okay, or which is equal to 0.99, which makes, okay, our threshold of error really just 1%, right? So that's our threshold of error within here. Now, we want this to be, okay, so notice that the tablets are 500 milligrams plus minus, okay, 0.5 milligrams. So it's actually less than the standard deviation, so we don't want our error to be very big. And then we're asking how big of a sample size should they test, right, if we want to have this confidence level of 99. So, well, let us try to do that. So what this relates back to is the following. So I'm going to just copy this down right here. So copy it, all right, so when we have this, okay, that we're going to try to find. Now, this z-score, okay, relates back to our confidence level. Now, again, so some confidence levels, like 99%, is a standard one. So, you typically will have in the tables 90%, 95%, and 99%. I've shown it in the videos, and you'll see that in the introduction to that confidence levels that I pointed out at the beginning of this video. But let's say if you wanted to start from scratch, you can look this up on a table, or as I've shown in that particular video, I like to do it, okay, through decimals. So we know we have a normal distribution, okay, so this is between, okay, a mean of 0 and standard deviation of 1. So that is, okay, our normalized standard, our standard normal distribution. So we can find the z-scores from here. And in order to do that, okay, on decimals, for instance, you need the CDF, so the continuous distributive function. Okay, so we want to try to find out, so we want the inverse of this, CDF. So this actually finds, so notice I put dot because I'm relating it back to that function. And I want it at 99%. Now, 99% level means that my threshold is 0.5%, threshold divided by 2 is 0.5%, right? So if I go back in here, right? So within here, this what I'm trying to find is I'm trying to find the z-score of really 0.5%, all right? Because that's theta right here divided by 2 because it's on the opposite sides, right? So this goes back through the confidence levels. So if I go back to decimal, so really, okay, what I have in here is, and I'm trying to find 0 point. Now you enter it not as a percent. Actually, let's see if we do enter it as a percent, 99.5%. Okay, no. Okay, it doesn't let you do that, I guess. So let's put 0.995. All right, and it gives you the Z score back. Now, again, this is a standard, so 2.576. So what I'm doing is I'm trying to find the normal distribution, right, to that point. Okay, so on the right-hand side, I'm finding my Z score for this. So that Z score, I'm sorry, just hold on a second, 2.576. That's right, I should know it. So that's going to be 2.576. So that's this right here. My standard deviation is 2.5 milligrams. All right, so that's what that is. Now this is going to be divided by, so this is going to be the square root of n, right? And then we want this whole thing to be less than the error. Now the error, okay, so that's from the question. So that's our error, which is 0.5 milligrams. Just make sure that those units, so these units right here, okay, are consistent. So now what I can do is I can actually solve for this n. So I can, rearrange this formula. So this is going to be n, or square root of n, okay, right here. Then on the left-hand side, it's 2.576 multiplied by 2.5, okay, divided by, 0.5 right here. And now, okay, so I can take the square root of both sides, sorry, square root. I can take the square of both sides, and that's going to give me my restriction on n. Okay, so how big should my sample size be? So this would be, 2.576 multiplied by 2.5 divided by 0.5 in brackets raised, okay, and then square it. So this is about, I guess, 166. So n should be bigger than that. So that's a pretty big sample if we want such a nice big confidence gap within here, or a confidence level, all right, within there. So that's how you would do it. And in general, okay, you can certainly isolate this formula. And they do that, okay, so they would do that sometimes in textbooks. They'll have this formula and then they'll isolate it for n, which you can do by just simple algebra, okay, so isolating for n. And then within this, okay, you can then solve for n. Now, of course, this is saying that n has to be, okay, at least 166 or bigger, right? So maybe you could have taken 170 and then checked if this was actually the case, right? That's what they would have. So that's how you can go backwards and reverse. So instead of finding your confidence levels from a sample, okay, sometimes we want to go back and reverse and say, well, how big of a sample should we have if we want to have a confidence level of, let's say, 99%, and then some error term, okay, so plus minus, okay, within the mean that we might be finding out, okay? So that's one example. Now, in the videos on confidence intervals, okay, and then confidence levels, you also saw, okay, proportion of population. So within these, you also had these confidence intervals within here. So this is the same thing, except we were talking about a proportion of a population. So maybe opinion polls that we had. And then again, I did a video on this and an example. So I'll put that up above there. So it was a series of a couple of videos. First was the introductory one on confidence levels. And then I, took it a step further to talk about this proportion of a population. So when you're not just talking about a normal distribution, okay, with respect to something, for instance, like this, okay, that we just did up above there, but you are interested maybe in opinion polls within, okay, to see what proportion of the population maybe supports or is against some opinion, okay, or whatever question that you might be asking them. So within here, so our error term, so this really, okay, is this right here. So this isn't any different, okay? So again, so this comes back through our standard, okay? So this is the same, right? This is kind of like having a binomial distribution and then being, trying to model it by a normal distribution. So this would have been my Z score. So that's the same thing as I had. Now my standard deviation is actually taken from the sample itself. So that is the P stands for the probability. So P, okay, with the bar over it just means the probability from the sample that you took. And then 1 minus p, okay, is the opposite. So if you take the square root of that, so you kind of have like your standard deviation right here. Okay, so it looks very similar, okay, to what we would have normally, okay, within there. So I'm assuming, okay, that you've seen this, and if not, then again, you can watch that video that I just pointed out. And then, you know, how does this relate back? Well, so this also relates back to these types of questions. So I'm going to copy this, okay, so you might see something like this. You know, so in a recent study, let's say 13.1% of those surveyed have reported symptoms of a fever in the last 30 days, okay? So this tells us that about 13% of the population, this would have been my P, okay, bar, has reported, okay, that they have had a fever, all right, in the last 30 days. So maybe this is sometimes in the fall or in the winter or something like that, where, you know, a few people might have or run into some kind of symptoms of a fever. The news article reports that the results are plus minus 1%, okay? So we really, what we want is we want this to be, you know, plus minus 1% off. And it says 19 times out of 20. Now, what is this 19 times out of 20? So now by, you know, viewing videos on confidence levels, you know that 19 out of 20 is nothing else but simply a confidence level of 95%, okay? And that would mean that the Z-score, okay, of, you know, so your threshold over 2 for 95%, okay, is equal to 1.960, okay? So again, so this typically comes from tables, but if you're stuck, you know, you can go back in here to decimals, right? So this is, we had 95% confidence level. So that would have been, my threshold is 2.5% on the left and then 2.5% on the right. So this would have been 97.5. So we have, so we had that. Okay, so notice that's 1.96, as I pointed out. Okay, within here, so that's my Z-score. And now if I want to be able to substitute it back into here, so if I'm solving this whole thing, so I want this error to be less than, okay, or equal to, so now this is, you know, 1%, okay, that I have in here. I'm going to change all of these, so 1% to decimal, okay, so I can do this, and now substitute this whole thing. So 1.960, okay, so times, and now the square root, so this is going to be 13.1%, so 0.31, okay, multiplied by, and this is going to be 1 minus 0.131, okay, and this is divided by, okay, the square root of n, and we want, you know, to know how big was the sample size in here, so we can certainly solve this again, and then isolate it for n. So, you know, if I do this, okay, so throughout, so not a very big deal. Let me just copy this down so I don't have to rewrite it. So I have that. Okay, so these two will swap. Obviously, this will go down, this will go up. So this is going to be square root of n. And then this now becomes 0.01. Okay, so we have that. So what is that equal to? And then I can square both sides. So let's see what happens here. 1.96 multiplied by the square root of, and this was 0.131 times, I guess 1 minus 0.131, so all in brackets, and then divided by 0.01. So this is, okay, my answer. Oops, syntax error. Oh, I didn't put the, let me go back, I didn't have that. So that's 66.1, you know, so 66.13, so on. Okay, and this is supposed to be that. So now squaring this, so if I take this and now I square this, so raise it to the 2, I'm going to get exactly my sample size. So the answer equal to squared So this is actually rather large, okay, that I would have. So what was this equal to? So this is going to be a huge sample size. So 4,373, okay, approximately. Okay, so this has to be that. Now we want it because it's point something, right? So we can raise this up. So let's say, you know, we round it off. Okay, now you can round it to, you know, however your teachers are actually asking you to round these. But this is something that you would run into, and you can certainly, you know, do this, okay, within here, and then find out exactly how big the sample sizes should be if you are interested in results like this. So there you have it. So those are a couple of examples. So basically going from an error term and then finding it out. So the reverse of confidence intervals to try to see. So here's my, you know, my confidence interval is between here. So centered around 13.1, and then it goes -1. So between 12.1 and then 14.1, right? And then how big of a sample size should we have? Well, you know, we can certainly do the calculations for this, okay, and then find this out. All right, so that is it. Okay, so thanks for watching. I hope that you found these couple of examples useful, okay? And I guess goodbye to data management for now. Take care. See you in a future course. Bye, everybody.